My name's Collin Murphy. I am a senior on the Bucknell men's soccer team, and I'm a biomedical engineering major. 2 summers ago, I did research on deep brain stimulation in treatment of Parkinson's disease. So, deep brain stimulation involves the permanent implantation of electrodes deep inside the brain to stimulate structures that are associated with the symptoms of Parkinson's disease. So these electrodes deliver electrical impulses with a certain frequency or amplitude as dictated by physicians and can have therapeutic effects on patient symptoms. In particular, the research that I did looked into trying to correlate anatomical features of the subthalamic nucleus, or the STN, which is typically the target structure for deep brain stimulation of PD. And I was trying to correlate its geometric or anatomical features with patient outcomes. So, trying to allow a physician to view an STN on an MRI or any kind of imaging technique, say, is this a thick or a thin STN? Is it long or is it short? And based on that, they could identify where within the STN is optimal to stimulate for patient outcomes. The reason that this research is important is because there's no cure for Parkinson's disease at the moment, and previously patients were put on different dopaminergic drugs, or drugs that pretty much produce more dopamine in the brain, and these can produce a lot of different side effects, even make patients' symptoms worse, or as the disease progresses, they'll be reliant on the drugs and they'll have to increase their dosages. So there's a lot of problems with taking the drugs related to it. So while we wait for a cure, improving deep brain stimulation can really improve patient outcomes.